All machines require some degree of regular servicing, and unfortunately the car is no exception. But if you intend to carry out your own maintenance, then it can be pretty confusing if you don't understand how the car works in the first place. So we'll be explaining the mechanics as well as showing you how to maintain your car. Now this is the second of two programs, and in this one we'll be looking at the steering, the transmission, the brake and the suspension systems. The first program dealt with the engine and its associated systems. But to help you to refer back to any particular section in the video, a number will appear in the top left-hand corner of your screen. That number will change every 2 minutes, and it'll refer directly to the number that's printed on the menu at the back of your video cassette cover. But just before we begin, one word of warning. Working on a car can be dangerous. Beware of any moving parts. Never wear a tie or any loose-fitting clothes. And if you need to look underneath the car, then make sure that the vehicle is properly supported. Okay, let's first look at the transmission system. Power from the engine is transmitted through the gearbox, rear axle and road wheels by the clutch assembly, which is situated inside the bell housing between the engine and gearbox. This disconnects the engine from the road wheels whenever the driver changes gear. The assembly consists of a friction plate, which is attached to the gearbox input shaft and sandwiched between the flywheel and a diaphragm spring. The diaphragm is enclosed in a pressure plate attached to a cover known as the clutch housing. The whole assembly is then bolted to the flywheel. As the flywheel rotates, the friction plate is clamped against it by the diaphragm spring, causing it to rotate at the same speed. This in turn causes the gearbox input shaft to rotate. The foot pedal inside the car is connected either hydraulically or by a cable to an operating lever protruding through the bell housing. When the pedal is depressed, the lever pushes a thrust bearing in to release the spring pressure on the friction plate. The plate then moves away from the flywheel so that the gearbox shaft and driving wheels stop rotating. With the pedal released again, contact is renewed, sending power along the main input shaft to the gearbox. Eventually, the friction lining wears down and the plate has to be replaced. With most rear-wheel drive cars, this involves removing either the gearbox or the engine. Both of these jobs vary considerably from car to car and are beyond the scope of this program. Most modern cars are fitted with a cable-operated clutch. Some of these are self-adjusting, although in others the cable needs to be tightened from time to time as it stretches or as the friction lining wears down. Measure the amount of free play in the cable before making any adjustment. This is usually done at the bell housing, under the bonnet at the bulkhead, or at the clutch pedal. If the free play is more than the amount specified in the handbook, take up the slack by moving the position of the cable lock nuts. If the cable has stretched so much that adjustment is impossible, or it has a frayed strand of wire, you'll need to replace it. This is really quite straightforward, but make a note of the route that it takes before disconnecting both ends from the pedal and bell housing. Thread the pedal end through the bulkhead and remove it from the car. Remember to keep any clips and springs so that you can reuse them. Check that the new cable is identical before refitting and adjusting for the correct amount of free play. The majority of hydraulic clutches are self-adjusting and need little maintenance apart from topping up the master cylinder with universal brake and clutch fluid. But there are a few hydraulic systems that can be adjusted, so check your handbook to find out whether this is necessary. In cars fitted with automatic transmission, the clutch assembly is replaced by a torque converter built into the gearbox. This is centrifugally operated to engage drive at the correct engine speed. These units are highly complicated and any kind of repair needs specialist training, so don't attempt to do it yourself. The higher the engine speed, the more power is produced. Most engines develop their maximum power at over 4,000 revolutions per minute. But the road wheels only need to turn at around 1,000 RPM to achieve a speed of 70 miles per hour. So the car needs a system which allows the wheels to turn once for every 4 turns of the engine. This is done by the final drive unit, which forms part of the rear axle. But if the car is moving slowly or climbing a hill, the engine won't be producing enough power or torque to propel it. So we need a second system which allows it to turn faster in relation to the speed of the road wheels. This is the purpose of the gearbox. Basically, the unit consists of an input shaft connected to the clutch and an output shaft leading to the final drive unit mounted in the rear axle. These shafts are connected by any one of a number of helical gear arrangements. The lower the gear, the faster the engine turns for a given road speed. The car's gear lever is linked to a system of selectors inside the box, and the appropriate gears are selected manually by the driver. In an automatic gearbox, the torque converter drives a pump which changes gear automatically using automatic transmission fluid. In rear-wheel drive cars, power is transmitted from the gearbox to the final drive by the propeller shaft. Both ends of the shaft are fitted with a universal joint to take up any movement between each part of the transmission. In the case of front-wheel drive cars, the output shaft from the gearbox runs directly into the final drive unit, so no propeller shaft is needed. Each drive wheel is connected to the final drive by a half shaft fitted with a constant velocity joint, enabling the wheel to be steered and driven at the same time. The oil level in the gearbox should be checked regularly. Unscrew the filler plug on the side of the casing and use your finger to test the level. It should be just below the filler hole. If it needs topping up, remember to use the correct oil, usually SAE 80, SAE 90, or on some models, engine oil. With the plastic tube securely attached, squeeze the oil into the gearbox. Some models may have a drain hole on the bottom of the unit. If so, change the oil completely at the recommended intervals by removing the plug. With automatic gearboxes, hydraulic fluid is used instead of the normal gearbox oil. These usually only need topping up and are provided with a dipstick similar to that of the engine. Make sure you use the correct grade of fluid for your car. As well as gearing down the engine so that the driving wheels turn at a suitable speed, a differential gear system inside the final drive housing allows each wheel and half shaft to turn at different speeds. This is necessary when the car is turning a corner, so that one wheel has to travel further than the other. Some modern cars have final drives which are sealed for life, so you don't need to change the oil. Your car's handbook will tell you whether this is the case. If not, the axle will be included as part of the regular maintenance schedule. Changing the oil follows the same procedure as used for the manual gearbox. Once again, make sure to use the correct grade, usually EP90. Your tyres form the only contact between your car and the road, so obviously they're vital for safety. Never take risks with badly worn or damaged tyres. Always fit replacements made by a reputable manufacturer. They may be slightly more expensive, but the materials used and the method of construction will be far superior to the cheaper versions. Let's take a closer look. Modern European tyres fall into one of two categories: the cross-plies and the modern radials, which have now replaced them. Now, all tyres have bead wires bonded into the rims to help locate them on the wheel. But the construction of the two types of tyres are entirely different. The cross-plies have layers of parallel textile cords laid diagonally on top of each other to form the casing, onto which the sidewalls and the tread are then bonded. This means that any movement of the sidewall is then transmitted directly to the tread to give bad grip and rapid wear. But the radial tyres, though, are made up of one, or in the case of high-performance tyres, two layers of parallel cords running at right angles to the bead wire. But here the tread is separately braced with two or more layers of steel cord. This means that the sidewalls and the tread work independently of each other. And the firmer tread gives a longer life and much better grip. But to actually make a tyre that'll do this is not easy, because the stresses between the supple sidewalls and the firm tread can cause problems. It's a lot easier and far less costly to produce a radial which has a less firm tread and stiffer sidewalls, as happens in the cheaper radials. And the results lead once more to a distortion of the tread. But is all this really important? Well, take a look at this. With the cross-ply or the cheap radial, any movement of the sidewalls causes the tread to shuffle. But with the good radial, the supple walls allow the tread to remain firmly on the ground. Consequently, the vast majority of new cars are fitted with radial tyres. The tread pattern is made up of a number of blocks separated by channels or grooves to clear the water from the road surface. Some tread patterns have small channels called sipes moulded into the tread blocks. These clear away even more water or reduce heat build-up. The size of the tread blocks is varied to reduce the noise generated by contact with the road. When replacing a tyre, make sure that it complies with the car maker's size, speed and load ratings. You can identify a tyre by the various markings on the side wall. In this case, the number 185 means that the tyre is 185 millimeters wide when inflated. 70 is the aspect ratio or profile, with the height of the sidewalls being 70% of the inflated width. Not all tyres have an aspect ratio marking. R means radial construction, and 13 represents the wheel diameter in inches. 86 is the load index for the tyre. The actual carrying capacity can be obtained from any tyre manufacturer using this number. And T is the speed symbol, representing the speed at which the tyre can carry this load. The most common speed symbols are R, 170 kilometers an hour, or approximately 105 miles an hour, S, 180 kilometers an hour, or approximately 113 miles an hour, T, 190 kilometers an hour, approximately 118 miles an hour, H, 210 kilometers an hour, or approximately 130 miles an hour, V, 240 kilometers an hour, approximately 150 miles an hour, and Z, over 240 kilometers an hour, or over 150 miles an hour. Finally, make sure that new radial tyres carry an E marking. This means that the tyre meets the minimum legal standards required for all European countries. Some older cars are fitted with tube tyres, which contain an inflatable inner tube inside the main carcass. If you've got tube tyres, always replace the tube itself whenever you fit new tyres. But all modern cars are fitted with tubeless tyres, which are sealed onto the wheel rim by the bead area. The word tubeless will be marked on the sidewall. Check the air pressure in your tyres once a week, including the spare. To obtain an accurate reading, this should be done when the tyres are cold. Otherwise, the heat generated by contact with the road will increase the pressure and give a false reading. Remember, it's the air pressure that tensions the casing, enabling the tyre to carry the load. Unscrew the valve cap and check the pressure using a hand pressure gauge. If it's lower than the pressure given in your manufacturer's handbook, use a tyre pump or a garage airline to increase the tyre pressure to the correct figure. If it's too high, press in the valve core pin to release air until the correct pressure is attained. Recheck the pressure again after making any adjustment, and always use a valve cap, not only to protect the valve, but to act as a further seal. Check the depth of the tread pattern regularly using a tread depth gauge. By law, the remaining depth must be at least 1 millimetre across 3/4 of the tread width in a continuous band around the entire outer circumference of the tyre. And the original tread pattern grooves must be clearly visible on the remaining quarter of the tread width. Most tyres have tread wear indicators which appear as a bar when the remaining tread pattern depth reaches 1.6 millimetres. If you're taking your car abroad, check the tyre regulations for the countries you're visiting with a motoring organisation. They may require a greater remaining tread depth than in the UK. Ideally, the same type of tyre should be fitted to all 4 wheels of the car. Although the law allows the use of cross plies on the front with radials on the rear, it's both illegal and may be dangerous to fit radials on the front and cross plies on the rear. It's also illegal to mix tyres of different construction on the same axle, in other words, cross ply and radial. Make regular checks for any lumps, cuts or bulges, and remove any stones wedged in the tread pattern grooves. Have punctures checked by a professional tyre distributor. He'll remove the tyre from the rim, and following examination of the interior, he will advise you whether it's suitable for repair. Of course, all tyres will wear out eventually, but in most cases, excessive wear is down to incorrect use or perhaps problems with the steering or the suspension. But unless you identify the cause, your new tyres could wear out just as quickly. Let's look at a few examples. Overinflation will cause the tread to wear in the middle first, leaving the tread either side in relatively good condition. Underinflation has the opposite effect, with the outer edges wearing before the middle. Sloped wear, or wear on one side of the tyre, is caused by either incorrect wheel camber, misalignment, or hard driving. Feathering is caused by the wheels being out of alignment, so that the tyre tread distorts as it's forced to travel in the direction of the car. Wheel alignment, or the toe angle, requires specialist equipment, so have it checked by professionals. Hard cornering and aggressive driving can cause rasping on the outer shoulders of the tyre. Another very common problem is vibration through the steering wheel, caused by an imbalance in the tyre and wheel assemblies. This can be transmitted by the front or rear wheels, and the end result will be patchy tyre wear and excessive wear in the steering and suspension components. Once again, specialist equipment is needed, so wheel balancing should be carried out by a garage or tyre distributor. This will reduce vibration to a minimum, as well as increasing the life of the tyres, steering and suspension. A flat spot on the tyre is normally the result of heavy braking, incorrect fitting, or a distorted brake drum or disc. Oil-based substances are harmful to tyre rubber, so avoid contact with oil, paint or fuel. If you do find any of these on your tyres, clean them off with an ordinary detergent. All new cars are supplied with a wheel brace and a jack. There are several types of jack available, but the one supplied will usually be a side lift jack or a scissor jack. The side lift locates in a tube or channel position just underneath the side of the car, and the weight is lifted by turning the handle in a clockwise direction. A scissor jack extends when the threaded screw is turned clockwise using the crank handle supplied. The jack head usually locates in one of the lifting recesses under the suspension or bodywork. Check with the handbook to find out where these are. You can buy more sophisticated versions, such as the hydraulic bottle jack or a trolley jack. Make certain that they have a large enough lift capacity for the weight of your car, and that they're not too big to fit underneath. If you use a bottle jack, first make sure that the ram is at its lowest height. Turn the valve anti-clockwise and press down as far as it'll go. Retighten the valve and position the jack under the car. Pump up the ram so that it rests under a piece of wood to prevent damaging the car. Keep pumping until the car lifts off the ground. Trolley jacks have the added convenience of wheels so that they can be slid under the car into the correct position. Make sure that the surface is flat enough for the jack to slide, otherwise it'll slip off the car's lifting point. You should never crawl under a car which is supported only by a jack. Always use additional supports such as a pair of axle stands. These should be positioned either under the jacking points or the suspension mountings. You can alter their height by sliding the locking pin through holes in the tubing. Use the jack to raise the car enough to slide the stands into place and lower it until it rests firmly in the cups. Wheel ramps are even safer if you don't need to take the wheels off. They can be used to raise either the front or rear end of the car, and to stop the ramp slipping, loop 2 lengths of old carpet through the bottom rungs. With the front wheels straight, drive the car slowly up until the wheels rest centrally on the flat top. Then chock the pair of wheels still on the ground. The first step in changing a wheel is to remove hubcaps or wheel covers according to the instructions given in the handbook. Next, loosen off all the wheel nuts half a turn using the wheel brace supplied. If they're too tight, you can gain more leverage by extending the brace with a length of metal tubing. Fit the jack to the nearest jacking point and raise the car until the wheel is clear of the ground. Remove the wheel nuts completely and pull the wheel off the hub. Refit the spare wheel and replace the nuts until they're finger tight. Lower the car completely and tighten the nuts in a diagonal sequence using the brace. Refit any hubcaps or wheel covers. The car's steering wheel is connected by a column to a steering rack assembly positioned horizontally between the front wheels. This contains a sliding shaft driven by a small gearbox. The rotary movement of the steering wheel is converted by the gearbox into a side-to-side movement of the shaft. At each end of the shaft is a ball joint linked to a track rod arm which is then connected to the front wheels. Some larger or more powerful cars are fitted with a hydraulic power-assisted steering system as part of the standard equipment. This reduces the effort needed to turn the steering wheel, especially at low speeds. Most systems consist of a pump driven from the engine, a separate reservoir containing automatic transmission fluid, a control valve operated by the steering column, and a hydraulic ram inside a cylinder connected to the steering rack. If for any reason the power steering hydraulics fail, the steering rack returns to normal non-assisted operation. As part of regular maintenance, check the condition of the rubber gaiters covering the ball joints connecting the track rods to the steering rack. If there are any signs of damage or splitting, they should be replaced to stop dirt getting into the steering. Check the outer ball joints connecting the track rods to the steering arms on the wheel hub assemblies. Look for any sign of damage to the rubber seal. Using an assistant to move the steering wheel from side to side, watch the action of the joint. As the rod changes direction, there should be no play between the ball joint and the steering arm socket. If any play is present, check that the locking nut is tight. If it is, then the joint is worn and needs replacing. Whether you're changing the joint or just the gaiter, you'll need to disconnect the track rod from the steering arm socket. With the car raised and the road wheel removed, brush off any dirt from the locking nut. Spray the nut and joint liberally with penetrating oil and allow it to soak in for a while. Remove the split pin and unscrew the nut to the end of the ball pin. Fit a ball joint splitter between the pin and the steering arm. Tighten the bolt on the splitter until it forces the pin out of the arm. If the pin is very tight, you might need to tap the head of the bolt with a hammer to break the joint. With the splitter removed, take off the locking nut and lift the ball joint out of the socket. Next, Undo the nut securing the ball joint to the track rod and unscrew the joint, counting the number of turns needed to remove it from the rod. On some cars, the left track rod may have a left-hand thread. Thoroughly clean off any dirt from the steering arm socket as well as the track rod and gaiter. If you're changing the gaiter, release the clips at both ends and slide it off the track rod. Most steering racks are filled for life unless the gaiters are removed, so repack the ends with the recommended lubricant, working it in by turning the steering from side to side. Then retighten the clips. Screw the replacement ball joint onto the track rod using the same number of turns as before, and insert the pin into the steering arm socket. Coat the thread with an anti-seize compound and replace the lock nut. Retighten the securing nut at the other end of the ball joint, and finally protect both joints with a coat of grease. When you've finished both sides of the vehicle, you'll need to have the wheels aligned accurately to avoid excess tyre wear or steering problems. This is called tracking. To compensate for the small amount of free play which exists in all suspension and steering systems, the front wheels are deliberately misaligned to point slightly in or out when the car is stationary. This toe in or toe out varies from car to car and is usually less than 5 millimeters. Specialist equipment is needed, so take the car to your local tyre and exhaust centre where they'll use proper alignment jigs. On cars fitted with power steering, the fluid level in the reservoir should be checked regularly and topped up as necessary with an automatic transmission fluid.
Suspension systems vary from car to car, but most absorb the bumps and undulations by use of a coiled spring attached to the wheel hub assembly. A fluid-filled damper prevents the spring from continuing to oscillate after the bump has been absorbed. And usually an anti-roll bar is fitted, which reduces the amount of body roll when the car is cornering. All modern cars are fitted with independent front suspension, so that each wheel has its own spring and suspension linkage, which allows it to rise and fall independently.
Rubber bump stops prevent the wishbone from hitting the car body under extremely bumpy conditions. The second commonly used arrangement is the McPherson strut system. In this case, the top end of a long telescopic strut, incorporating a coiled spring, is flexibly mounted to the body inside the front wing. The bottom end is attached by a swivel to the wheel hub assembly, which is then mounted on either an A-shaped transverse link or a single track control arm connected to the anti-roll bar. In both cases, the link and the arm are mounted to the body and are able to move up and down. The simplest rear suspension system is the beam axle, attached to a pair of telescopic dampers and springs which are fixed to the body. Older cars tended to use leaf springs mounted longitudinally, but modern cars normally use coiled springs instead. With this type of system, the differential and drive shafts are enclosed in the casing or beam axle, so the rear wheels are not independently suspended. Although the McPherson strut is sometimes used for the rear wheels, independent rear suspension is usually provided by a trailing arm system. Each rear wheel is supported by an arm which is hinged at right angles to the body of the car. A damper and coiled spring mounted between the arm and the car's structure absorb the bumps. In this case, the final drive unit is also fixed to the car, while the drive shafts run through bearings on each arm to the wheel hubs. Each shaft is fitted with a universal joint at both ends, allowing it to move up and down with the wheel and trailing arm. Better road grip is obtained by angling the arms outwards, This is known as a semi-trailing arm system and is probably now the most widely used form of rear suspension. The suspension system should be examined regularly by checking all rubber bushes and linkages for signs of wear. Make sure that no securing nuts or bolts have worked loose, and pay particular attention to the front suspension mountings. Use a suitable lubricant to protect all joints and linkages from dirt and to prevent squeaks. With the car jacked up, check the play in each wheel bearing by gripping it at the top and bottom. This is very important on the front wheels, where a faulty bearing can cause steering problems. Use an assistant to hold the steering wheel firmly while you rock the wheel back and forth. There should be a certain amount of play, but if this is excessive, the bearing should be adjusted. Most wheel bearings are protected by a knock-off dust cap. Remove this by tapping and levering it away from the center of the hub. Pull out the split pin and tighten the retaining nut to the correct torque specified by the manufacturer. To do this, you'll need a torque wrench, which shows how much torque or turning power is being used. Stop turning the nut when the pointer gives the correct reading. Telescopic dampers are maintenance-free, but you should check their behavior regularly. Look out for excessive bounce. Press down heavily on each corner of the car in turn. If it bounces easily or feels soft, then the damper should be replaced. If the car rolls excessively when cornering, or if you can see any leaking hydraulic fluid, again the unit should be replaced. Damper mountings vary from car to car, and you may need to dismantle other parts of the suspension and steering to get the old unit out. So once again, it's far quicker and usually just as cheap to have the job done professionally. To be on the safe side, always change shock absorbers in axle pairs. If you change one on its own, you may affect the car's handling. All modern cars are fitted with a hydraulically operated braking system. This consists of a fluid reservoir and a master cylinder, which is operated by the brake pedal. A network of metal pipes and hoses carry the pressurized fluid to 4 brake assemblies, one for each wheel. As the brake pedal is depressed, the cylinder forces fluid under pressure to the brake assemblies. There are 2 types of assembly. The front wheels are fitted with a disc brake unit, consisting of a metal disc which revolves with the wheel. Part of the disc is surrounded by the brake caliper, containing hydraulic pistons. These force 2 friction pads to grip the sides of the revolving disc and slow the wheel down. The second type of brake mechanism is the drum brake. An open-ended metal drum rotates with the wheel and is sealed by a fixed backplate. Inside are 2 semicircular friction shoes, separated at the top by a hydraulic wheel cylinder and at the bottom by an adjustment mechanism. As the brake pedal is depressed, the hydraulic fluid forces 2 small pistons out from each side of the cylinder. These push the brake shoes outwards so that they press against the revolving drum and slow down the wheel. In addition to the hydraulic system, the rear wheels have their own manual backup system operated by the handbrake. When the brake lever is raised, tension in the cables pulls on the pivoted lever mounted inside the brake drum. The lever applies one shoe, while a crosspiece simultaneously applies the other. Cars fitted with large disc brakes need a considerable amount of force to operate the brake pedal. A servo mechanism reduces the effort required by making use of the vacuum in the inlet manifold. The servo is fitted between the master cylinder and the brake pedal. As a safety precaution, modern cars are often fitted with dual circuit braking, where the hydraulic system is divided into 2 separate circuits. If one circuit develops a fluid leak, the second takes over. A further degree of safety is provided by an anti-lock braking system. Continuous heavy braking in wet or slippery conditions can cause the wheels to lock up, sometimes resulting in an uncontrollable skid. ABS systems solve this problem by automatically pumping the brakes on and off. The system senses when the wheels are about to lock and releases the fluid pressure accordingly. As soon as the wheels start to run freely again, the pressure is reapplied, and the sequence continues, allowing the car to stop in a straight line. Many new cars are fitted with a brake warning light to tell you when the fluid level is low or the handbrake is left on. In some cases, a separate warning light comes on when the brake pads need replacing. Don't rely solely on these. Check the hydraulic fluid level in your brake reservoir once a week. If it needs topping up, only use fluid which is recommended for your car. Check disc pads and drum brake shoes regularly for wear. Check the minimum lining thickness specified by the manufacturer. You'll find different figures for both disc and drum linings. You can inspect the disc pads without having to remove them from the caliper, and most modern brake drums have an inspection hole in the back plate which is covered by a removable plug. You may need a mirror and a torch to see properly. Linings should always be replaced in axle pairs, or in other words, a complete set of 4 linings. Never renew them on only one wheel. Finally, check all flexible hoses and metal pipes for any sign of fluid leakage. Don't forget to look at the master cylinder and servo unit as well. A sudden drop in fluid level in the reservoir is a sure sign of a leak. Disc brakes adjust themselves automatically, so the only regular maintenance needed is to replace the pads when necessary. With the car jacked up and the road wheel removed, turn the steering so that the side that you're working on points outwards. Note the position of the 2 spring clips and drive the retaining pins out of the caliper using a long-nosed punch or a blunt nail. Grip the outside pad with a pair of pliers, working it loose enough so that you can pull it out. Remove the inside pad in the same way. If it's too tight, you may need to twist it sideways to push the piston back into the caliper. If anti-squeal shims are fitted, note their positions and clean them thoroughly with brake cleaner. If there are no shims, smear a little anti-seize compound into the pistons and the rear surface of the pads to prevent brake squeal. The new pads will probably be too thick to insert into the caliper, so use a screwdriver to lever the piston back. Before you do this, it's wise to remove some of the fluid from the reservoir, otherwise it may overflow as the piston slides back. Clean out the inside of the caliper, but remember that brake dust is harmful, so don't breathe it in. Insert the new pad and anti-squeal shim, making sure that the lining side faces the disc. Now lever the other piston back and slide the second pad into place. Clean the spring clips and retaining pins and refit them to the caliper. Lower the car and repeat the process on the other wheel. Finally, recheck the fluid level in the reservoir and top up, if necessary, with the fluid specified in your handbook, usually either DOT3 or DOT4 grade. The method used for removing disc pads can vary slightly depending on the type of brake caliper fitted to the car. If yours has Girling calipers, first unscrew the upper guide bolt. Then swing the whole unit away from the disc to gain access to the pads. Check with your car's handbook to find out whether or not you have self-adjusting drum brakes fitted to the rear wheels. If you haven't, adjustment should be carried out at the recommended intervals. If the car is rear-wheel drive, put the gearbox into neutral and chock the front wheels to prevent it from rolling forwards. With the handbrake off, jack up the side to be adjusted. Rotate the wheel to make sure that it moves freely, though there will be a certain amount of drag produced by rear-wheel drives. Most drum brakes are fitted with either a single screw-in adjuster or a hexagon wheel protruding through the backplate. In some cases, 2 hexagon adjusters are fitted, one for each shoe. Use a special brake adjusting spanner for the screw-in type. Rotate the wheel in a forward direction while turning the adjuster until the linings lock against the drum. Then back it off again until the wheel rotates freely. Repeat the process using the second adjuster, and again on the opposite wheel. Regular adjustment of the rear brakes should normally keep the handbrake working properly, unless the cables have stretched. If the lever travels an excessive distance before the brakes operate, you'll need to shorten the cable length. First, adjust the rear brakes as normal using the backplate adjusters. With the rear of the vehicle raised, make sure that the handbrake is fully off. Most systems use a single cable running from the handbrake lever through an equalizer bracket to one wheel. A second cable connects the other wheel to the bracket. Locate the adjustment nuts at the end of the main cable and using a pair of spanners loosen the lock nut. Tighten the adjuster nut until any slack is taken out of the cable. Then retighten the lock nut. Check for the correct tension by pulling the handbrake lever onto its first notch. You should just be able to feel the brake linings dragging against the drum as you rotate one of the rear wheels. The layout of drum brake components can vary from car to car, but all of them involve a system of springs and struts to position the linings correctly. You'll need to remove all of these to change the linings. With the handbrake off and the grounded wheels chocked, jack up the car and remove the road wheels. Some cars have retaining screws holding the brake drum in position, so undo these first. Alternatively, spring clips may be used to lock the drum to the wheel studs. Tap the drum gently with a soft-headed hammer and pull it away from the hub. Before you go any further, check that the new linings match the old ones exactly. Each lining is held steady by a spring clip connecting it to the backplate. If these are the pin and sprung washer type, grip the edge of the washer with a pair of pliers. Holding the pin from behind, twist the washer through 90 degrees until the flange of the pin passes through the slot. Then lift off the washer. Remove the spring and pin and repeat the process for the other steady clip. Alternatively, if the clips are the spring wire type, you'll need to compress the ends from behind the backplate and withdraw the clip from the front. Now lever the lower ends of the linings apart until they're clear of the pivot bracket. Release the handbrake mechanism and remove the linings. Disconnect the upper return spring and discard the old linings to avoid confusion. Make sure not to press the brake pedal at this stage, otherwise the hydraulic fluid will force the pistons out of the wheel cylinder. To avoid breathing in any dirt or dust, clean all of the reusable parts with brake cleaning spray, as well as the backplate and wheel cylinder. Smear a little high melting point grease on the wheel cylinder pistons and the pivot bracket.
Lay the linings out on the floor so that the friction surfaces are in the correct position and refit the lower return spring. Refit the strut and upper return spring, then reattach the handbrake mechanism. Pull the linings apart and slide them into place over the pivot bracket. And finally, fit new steady clips.
Replace the brake drum and road wheel and repeat the process for the other wheel. When both wheels are completed, you may need to readjust the handbrake as before. To work efficiently, the hydraulic system needs to be completely free of air. If any of the brakes have been replaced, repaired or adjusted, you might find that the pedal has become spongy due to the presence of air in the system. This should be removed or bled using a pressure bleeding kit available from most motor accessory shops. Remove the cap from your brake reservoir and fit one of the special caps provided with the kit. Attach the clear tube from the pressure bottle and fit the cap to the reservoir. Remove the lid and fill the pressure bottle with the recommended brake fluid. Then attach the black air hose to the nearest tyre valve. All that remains is to bleed the brake at each wheel by connecting another length of clear tube to the bleed valve. Loosen the valve half a turn and allow the fluid to run into a jam jar. When no more air is visible, retighten the valve. Repeat the process for each wheel, starting at the furthest from the master cylinder and ending with the nearest. Brake fluid should be changed completely at the intervals specified in the handbook. Remember to keep it well away from the paintwork and don't get it on your skin. The bleed kit can be used in the same way for bleeding or replacing hydraulic clutch fluid. All brake assemblies should be cleaned from time to time. If you use spray cleaner, you can do this without having to dismantle any of the parts or readjust the system. If you disconnect or replace any of the brake pipes, prevent leakage by applying a little brake sealant to the threads before reconnecting. If you'd like advice or more information on any of the items shown in this program, phone the relevant number and ask for technical inquiries.